All right, so here we have our serial adder controller or adder circuit with the controller. And so at the top right here, this is the controller which allows us to control the pace of the serial adder. And so it's basically like it lets it go through different stages. So right here you can see the state or different states: 0 idle, 1 is loading, and then 2 is adding, instead of us needing to like do all of that ourselves. And so we're going to go ahead and do C plus 7, which is going to be 12 plus 7. So first off, we're going to go ahead and do 8, 4, 1. So there you go. It's going to be 13. And then plus 7 is going to be 4, 1, 3. Okay. So then we start it up. And you can see there's 1 which is loading in the two numbers in. Now you can see that it's beginning to add them. And you can see right here in the counter is in the third phase of the adding, so it just needs 1 more and it'll be complete. And there you go. You can see this is a sum, and the counter is right here, and it shows that it's a total of 21. So that's what we should be getting. But let's just go ahead and run it back but this time we're gonna have it auto propagate the clock. So we go ahead and start it. Let's go ahead and simulate auto frequency. Let's go ahead and do 2 hertz. Click enable. It's already in 1, so you gotta turn. You don't need the start on anymore. You can see it's beginning to cycle through. You see it's adding them now. It's in phase 2, phase 4, and boom. It's completed the addition, so there you go. 21 once again. So this makes it a lot easier than if we were running it by ourselves, having to do the adding and stuff by ourselves each time, like loading it in by ourselves, computing the addition by ourselves, having to count the amount of phases that we're going through. This does it all for you. So, and it stops once it's completed the addition. And then in order to restart it, you just have to start the switch, put the start switch at high again, and then run the clock back, and then just put any amount of any number or any quantity that you want to add together right here, which are the inputs, A and B input. But yeah, it's a lot more simple than the other one. And so the way this circuit works, to like break it down more simple, even more than what it is. Here we have the control and data path model. And so the way to better explain it is we have the external signals. You have 2 components and then 5 arrows. So 5 phases or 5 ways that the control or the circuit works, the way that the circuit actually works. And so we have the external signals right here, and you can see it's basically the boss, the one that runs everything, telling the workers and everyone else to like begin the production or like begin building the construction. And then the input data. So first, before we do like all that external signals and the boss telling them to to start the construction and everything. We need the resources, the products and everything that you require for the output that you want to receive, the output that is needed. And so once you acquire all that, then comes the external signals, which is like basically start it. You start the circuit, you start everything. And so from here, the control, the one that's running everything, which is the boss, the control signals are telling the workers, so the data path, to do this, um, do different tasks, whatever they want them to do, or whatever they need them to do. And so the data path then receives those signals and starts producing and doing everything that they're being told, or that it's being, or the signals that it's receiving. And so then once they do that and then they finish, they go back, they get back to the boss or whoever's telling them to run it, and they report to them what they finished, what they've accomplished. And so from there, it's just a loop that keeps going back and forth, back and forth. So basically like adding or like going through the motions, the phases that it needs to in order to finally at some point produce output data, which is what the outcome, what the intended outcome is that they want. And in this case, if it was like a construction site or whatever, it's going to be a house. And so, just to summarize everything, the input data is the first thing that you need to put, like the numbers or whatever you need, the whatever the circuit or the job needs in order to run the the process. And so you first acquire these, and then from there you can begin telling the circuit what you need it to do. So basically start everything, and then from there, the control signals are telling the data path what to do, and then once they do that, what they've been told, they report back, and they tell them more things to do, and it just keeps going back and forth, until eventually they accomplish everything that was needed to be done, and they receive an output data, which is the outcome, and what the circuit is intended to do, or whatever the job is that they needed to finish. And so a reason why design circuits with control units are a lot more useful is because the control unit regulates and integrates the operations of the circuit. And so it selects and retrieves instructions from the main memory in a proper sequence and interprets them so that as to activate the other functional elements of the system at the right time in order to produce the right outcome that it's intended to. So it just makes it overall a lot more simple and a lot more easier to control and maneuver to get it to do whatever you want.